Thank you. Thank you very much for having me. And I'm sorry I can't be with you here in person this year. Fingers crossed for 2021. So, as you said, my name is Nate Schutta. I'm based out of Minnesota. So, behind me, it's actually quite sunny. And so, thank you for hanging out this hour. I know it's a little late on your side of our wonderful planet. As was mentioned, I did this report, I think it's a little more than a year ago now, kind of my thoughts around architecture. I think the best way to describe me is architect as a service. Normally I go places. Now mostly I just sit here in my home office, but it's not all bad, by the way. I think it's kind of nice being around my family, although I do think my wife has probably had just about enough of me around the house. She keeps kind of poking and prodding, when are you going to get back on airplanes? It's like, well, I don't know, probably not anytime soon. But if you're interested at all in these kinds of topics, please take a glance at this. It's a lot of the stuff that I've thought about in kind of this architectural realm. I do have another report coming out soon, for some definition of soon. That's about microservices. There's sort of my take on how to, when should you use microservices, based on a blog series that I wrote about a year ago. That's going to be out in one of these handy little reports soon, for some definition of the word soon. We're here to talk about the cloud. Now, this is the space that I've occupied now for probably the last 5 years or so. And what becomes very clear when you go down this path is there's a lot of options when it comes to the cloud. For a lot of developers, the first thing they think of is microservices. And then you've got others that are saying, no, no, we're going to do modular monoliths. And of course, we can talk about containers and Docker and Kubernetes, but other people are very excited about functions and serverless. Everything's as a service today, which I think is kind of fascinating. I like to joke there'd be other things that'd be nice as a service, like pizza as a service would be great. At conferences, bathrooms as a service would be great. And we're all kind of grappling with, what does it mean to be polycloud? Should we just push all our chips into the middle with one provider? Should we spread our bets around? What do we do with all this? And it puts us as engineers in this position of, I got all these different terms and technologies and culture shift, and I got to make sense of all that, while realizing it's not just a technical problem, and there are real engineering issues you have to deal with. Now, I'd love it if I could just sell you a magic sparkle pony and all your problems would go away, but I can't. And so I think the real challenge for us is avoiding the pitfalls, because there are real pitfalls in this cloud native environment. We also need to be very aware of resume driven design. I have seen far too many instances of people saying, I need to use X, Y, ultimately because I want to put it on my resume. Now, I always think it's important to start to make sure we're all on the same plane. Let's level set a bit. What do we even mean by cloud native? And I saw this tweet. It made me chuckle. Ask your doctor if cloud native is right for you. And I do think actually there's some truth in that. We probably want to think a little bit about, does it make sense for us in this particular situation? Not every app is a good fit for the cloud, to be real honest. A lot are, but not all, not 100%. At its core, all we're really talking about here are applications that are designed to take advantage of what cloud computing gives us. And this is ultimately about how we create and deploy applications, but there's also a pretty heavy dose of automation and culture change and other things along those lines. It's not enough just to write out a check and get some new technology. There's a lot of shifting that happens in an organization, especially if you're used to these very long, lethargic, sort of year-long processes, and having all sorts of gates and everything to go through. That sort of is in conflict with what we're trying to do with cloud computing. Now, the cloud gives us some extremely interesting capabilities. I think we're all aware of the fact that I can scale up, I can scale down, I can do this all on demand. I don't have to try to make these guesses about how much capacity I'm going to need. I can, sort of come up with what I think is a pretty good normal state, and then I can scale up and down as necessary. I do technically have limitless compute, but I need to, of course, understand that additional fees may apply. So a friend of mine is telling me in his organization, the data scientists got very excited about the cloud, and they were running all these models and regressions, and they were spinning up all sorts of stuff. And one night they ran something particularly compute intensive, and apparently the next day their provider called them and said, listen, are you ever planning on doing that again? Because if you are, we're going to need to go buy additional racks, additional blades, because you took all of our compute in that region. And obviously they're happy to sell that to you. They're happy to take your money, but it isn't free. The fees on a lot of this can be hard to discern as well. There's a great set of tweets I've seen on this. This is one of my all-time favorites here. I keep getting this bill from AWS for 80 cents a month. And so I spent an hour trying to figure out what had turned on, and I turned a bunch of stuff off, and I thought I had everything. And well, now I got a bill for 23 cents. So some of this can be challenging, to say the least. I thought this was pretty funny too. I looked at the simple cost calculator, and where's the complex calculator, and how many instances of EC2 do I need to actually run it? There's a lot to be said for that. So I based on this tweet, just for fun, I went out and was poking around in their calculator, and yeah, it can be a bit daunting, to say the least. And it's a good reminder that because we have all these capabilities and because it's so easy to turn these things off, we can lose sight of just how expensive some of this can actually be. Another friend of mine, someone in her team had spun up a function in a dev environment just to play with it. Functions really cheap, and they forgot about it, and they left it running for a month. And at the end of the month, they had a $100,000 charge from their cloud provider just for that one function. That was a bit of an uncomfortable conversation, I'm sure, there from both the manager and the proverbial bean counters. I thought this was hilarious as well. Hey, we dropped our cloud costs by a bunch because we actually went in and just turned off things we weren't using. Because again, it's very easy just to turn these things on, play with it, try it, and then you kind of lose sight of it. You forget you tried that, you forgot to turn it off, and they'll happily take your money. I mean, I'm sure we've all subscribed to something and didn't realize we were subscribed, or didn't realize we're on auto pay, or however it works, and they're like, oh yeah, what is this recurring charge? Now, as much as we talk about this as an architectural pattern, and that's clearly part of it, it is this interesting combination of practices, techniques, technology. There's going to be some amount of agile development. I mean, you can argue, frankly, that cloud environments bring a lot of the ideals of agile to infrastructure. The ability to wait for that last responsible moment instead of having to guess how much capacity you're going to need. There's going to have to be some continuous delivery. There's going to have to be pipelines. You've got to have this be as automated as possible. We cannot, and frankly, it's been a long time since we could rely on the proverbial right click kind of build. But if you're still doing this by hand, if it's bespoke, artisanal, you're in for a world of hurt. There's just no way you can possibly react quickly enough in today's environments if everything is this one-off. And it's always surprised me when people relied on sort of humans to do these things, because we're notoriously bad at doing the same thing again and again and again. And my favorite example of that, of course, is golf. I play golf, and that's been one real positive of this sort of pandemic, is since I'm not flying, I have a lot more time to play golf, which is cool. But if you've ever tried that sport, and this is something I've tried to communicate to my son, you can't do it the same way twice. It's just impossible. You're always going to be different person, different day, different temperature, different conditions. It's just, that's just the way it is. It's probably going to be containers in some way, shape, or form. Could be some microservices, could be some functions. I do always like to emphasize that the impact to your culture is huge. And I think this gets short shrift, and that's a disservice, because there's so much that goes on in an organization when we go from that very traditional waterfall-esque approach, these long lead times, quarterly releases. It takes a lot of effort and can disrupt current sort of power structures, paradigms, approaches. You get a lot of people like, well, that's how we've always done it. Doesn't mean it's the right way to do it. Doesn't mean it's the best way to do it. Doesn't mean it's the good thing for us to do today. There's going to be some pretty serious DevOps aspects. This probably starts being called SRE, site reliability engineering. Again, a lot of that to me is just automation is your best friend. Now, I would say one of the most interesting shifts I've seen in my career is infrastructure. It's very different than when I first got started in software. And there's been this massive, massive shift. I'm old enough to remember when we built our servers ourselves. I mean, we ordered the parts, we put them together, literally push the CPU onto the motherboard. They were very bespoke and artisanal. And I love artisanal coffee, don't get me wrong. I start my morning every day with a couple shots of blue bottle espresso that I pull myself. I love that. It's my little ritual to get the day started. And that's fine for my morning coffee. It's not so great for my infrastructure, and the problem we'd run into here is after spending days, sometimes weeks, handcrafting these things, we started to treat them like pets. I mean, we usually gave them names. I was at one company where our servers were named after Simpsons characters. And I say that somewhat jokingly, but my son's actually watching Simpsons right now in the other room. He found that on like Disney Plus or something. And so now he's apparently trying to go through every season of Simpsons, which will probably take him the rest of the summer if we were to actually allow him to just consume TV at that rate. But we treated them like pets. And just for I guess matter of comparison here, these are my pets. This is Han and Chewie. Actually, Han is right over my shoulder back there, basking in what little sun I've allowed him as I close my blinds so you could actually kind of see me here. But these two little creatures are really members of the family, let's be honest. And were Han or Chewie to develop so much as a sniffle, my family would compel me to spend crazy amounts of money, I'm sure, to make them happy and healthy again. And we used to do that with our servers as well. We would spend countless hours, days, weeks making them happy and healthy and tweaking them and all these kinds of things. And of course, in this era in software, these servers were really heavily constrained resources and they were very, very expensive. There were billion-dollar corporations that existed just to sell us hardware. And so our accounting type folks said, hey, y'all got to get your money's worth out of that app server that we bought you because that's really expensive. And so that's why we built this software to allow us to put as many applications as possible on one of these very expensive pieces of hardware so we would maximize ROI, which always makes the bean counters happy. Now, that was good from a placate the accountant standpoint, but there were some really interesting unintended side effects of that. We now have shared resources. Now, some applications, unfortunately, took this as an excuse to just rely on a library or a DLL being there because, well, I know I'm installed on the same server as the Wombat app, and the Wombat app already includes that thing, so I'll just share that, or I'll take advantage of some piece of processing in the Wombat app because I know we're on the same box. One application's bug can take down a whole bunch of other apps. This actually happened to me one random Monday morning. I came into the office. One of my applications was down. I start digging into it, and I discovered that over the weekend, someone had put in a MIME type change. And of the 10 applications on the server, 9 were down. The only one that was working was the one that wanted the MIME type change. Now, I don't know why this wasn't found earlier. I don't know why this wasn't found in testing and QA and dev. I don't know. It doesn't really matter. And I don't know why a MIME type change caused that problem in the first place. But it was just another instance of one application makes a mistake or even just does something they think is benign and it affects everybody. Coordinating changes becomes a real pain in this environment as well, because I'm not free to just add whatever I want anymore. I have to wait potentially for months because whoever our slowest moving application is, well, they become the tent pole. They become the thing that forces us to say, well, hold on there, tough guy. You have to wait until we're ready. And every one of us has had that experience. You want to upgrade to the next version of Java or .NET or whatever it happens to be, and you're told to slow your roll because we're still waiting. This application, they think they might be able to do it in 2 or 3 years. Well, that means I'm stuck here. I don't want to be stuck here. This is no fun. These currency projects, and I've been involved in a lot of them, they're not a lot of fun. They always take longer than we think. Every time you start one of these, we're going to upgrade XYZ. You think, oh, it'll just take a few months. It always takes a year to 2 years. And there's all sorts of frustration because you have to tell your customers you're not going to get anything new for a while. And you got to do all this remedial testing. Oh, try it again, try it again. It's just not a lot of fun. And so it's no surprise to me that a lot of organizations looked at this and said, whoa, we're just not even going to worry about currency. Just kick that can down the street. It'll be somebody else's problem. We'll just wait for it to sort of metastasize into this ginormous, tumor in our organization, and then we'll deal with it because that's always the best way to handle a problem. Now, this has always made me think of this wonderful Yoda quote about, fear is the path to the dark side. Fear leads to anger. Anger leads to hate. Hate leads to suffering. Because this is what happens to us. It's all fear. It's fear of what will happen when we make the change. And it just leads us to this massive amount of suffering, which leads me to believe we've been practicing Yoda ops for most of our career and didn't even realize it. Now, of course, during this era of software development, I was moving code from one instance of an app server to another instance of an app server. And the funny thing here is inevitably you'd have that situation where, well, it worked in one region but not in the other. And of course, I've reflected upon this a lot in my career, but for a number of years as a developer, I worked on a Windows machine writing Java that was ultimately going to be deployed to an app server running on Linux. It's like, why wasn't I using at least a Unix variant in my day-to-day work? Why was I deploying on one? Well, it's because that was what the corporate standard was, and it was too difficult to change that. But that inevitably led to all sorts of quirks where, well, it worked on my machine, and then I pushed it to dev, and it didn't. Why not? And these are some of the most frustrating experiences that you can have as a developer. I mean, I've never enjoyed these experiences where I'm pounding my head against a table trying to figure out, well, it worked here, but not there. They're supposed to be identical. This is what my wonderful IT people are telling me. The infrastructure is identical. Probably the most egregious example of this in my career, we're clicking along on this project. Things are going really well. We were in one region, moved it to the next region, and everything blew up. I think it took us about 2 weeks to track down the root cause, and this one still drives me nuts. The difference between the machines is the order the patches were applied. So they're at the same patch level, same everything. Just one had the patches applied in a different order, and so there you go. And this is where you start to say, like, is there a better way to make a living? What life choices brought me to this place? And I've thought about that. Do like electricians have to deal with this kind of stuff where like the order I put the wiring together caused a problem? I don't know. Maybe it's even worse. I'm not sure. This is the only industry I know. Now, luckily for us, we've seen this shift. Things are starting to change, and we've started to treat servers as commodities. So instead of them being this very expensive, very proprietary thing that we buy from a handful of customers or companies, well, now we're using off-the-shelf stuff. We're using Intel chips. We're using Linux, and instead of these customized things, these specialized chips. And so that leads to another one of my all-time favorite tweets. What are clouds made of, Dad? Well, Linux servers mostly. I can say this and it makes my son kind of chuckle because he, is sort of, I guess, software adjacent. Although, proud dad moment, I think this was Tuesday morning. My son got up and told me I needed to teach him how to program because he and his buddy had come up with a wonderful idea for a game. Now, I have stressed to him just how long of a road it is from good idea for a game to building said game. But I take this as a positive. He wants to learn how to code, so I'm going to do everything in my power. My favorite thing is he asked me, Dad, do you have any books on programming? And I just said, have you seen the shelf behind me in my den? I mean, yes, of course I do. Now, interesting outcomes from this is because we weren't using these specialized things made by one or two or three companies, prices came down. And what also happened here is we realized that servers aren't the constraining factor anymore. Servers are actually fairly cheap. It's the people costs that are much more expensive than the hardware cost. And we started to see these new operating procedures come up, these new ways of doing business. Things like Heroku and AWS and App Engine and Cloud Foundry and Azure started showing us, hey, there's another way of doing this. And so we now realize that shared servers are actually a liability. Now, the shift here is instead of treating them like pets, which are essentially members of the family, we kind of need to treat them like cows. And when they get sick, you get a new one. If you've ever been on a large scale cattle operation, you realize they typically don't give the cows names, they give the cows numbers. And as much as we do care about the well-being of old number 15 here, if number 15 gets ill, there's a limit to how much we're going to spend to make 15 happy and healthy. We'll just get a new instance of 15. Now, that isn't always the case. I actually grew up on a hobby farm. We had cows mostly as pets, although we did name some of them as a reminder of what was going to happen to a few of them in the fall when it came time to process them. But we did frankly treat them kind of like pets. We had one, we named her Houdini because she knew how to get in and out of the pens at will. And we never quite figured out how she did. I think there was like a low spot somewhere and she figured out how to kind of roll under it. She never went very far because, she knew where mom was and she knew where the corn was and the hay. So she wasn't stupid, right? She was going to stick around. But I'll never forget one day sort of sitting in my living room and, you kind of have that feeling there's something over your shoulder. And I look back and there's this calf standing on my back porch, just wagging its tail, looking at me, wanted to be petted basically. So, she was kind of like this half-ton dog. She was very cute as she got older. But this gives us a new set of abstractions. Now I can use containers and platforms and just change the way we approach this. And so now instead of taking code, moving it from one instance of a server to another and fingers crossed, hope it all works, I just package the app up with everything it needs and I move that from one environment to another. And in fact, probably not even moving it. It's probably just changing a routing table. And so now if it works in dev, it's going to work in test because it's the same thing. This is a huge amount of win for us. Now, one of the biggest advantages as an application team, I'm given much more control now because if I need a spiffy new library, I'm free to add it. I don't have to wait until everyone else is ready. I don't have to wait until that very slow moving app can finally take that upgrade. I can just change it if I want to, because my change doesn't impact anyone else. Now, interestingly enough, I did get some pushback when I was having this conversation with one of our prod support people. This is many years ago, and his reaction was, "Well, yes, but all these libraries are going to be duplicated, and that's costing us extra money because we have extra storage space." And I mean, I had to bite my tongue to keep from just like audibly guffawing about this. I wanted to sort of like reach into my wallet and give him a couple of ones and say, here, this should cover us. Because let's be honest, it's so much less expensive than having someone like you wade through the debugging, and someone like you have to sit around and wait and have to tell your customer, I'm sorry, you can't have that new feature because it turns out this other app you're not even aware of can't take that change yet. And what it allows us to do is fundamentally move the value line. It gets us out of doing undifferentiated heavy lifting. As much as possible, we want to be above the value line. We don't want to be doing these things that our customers don't see, don't care about, could care less about. Now, not to say it's unimportant to patch and upgrade. Of course it is. But none of your customers are sitting there pounding the table saying, when are we going to get on the next version of Linux? They don't care about any of that. They don't care what distro you're on. They care about features and functionality of the application you're building for them. That's the business value they get out of this. Now, this also changes our approach to development, and I would say in a very positive direction, because we can finally embrace that notion of always be changing. So we can experiment, we can do A/B tests. For most of my software career, A/B testing was the sole purview of big tech companies like Google and Twitter and Amazon. And woe be some regular enterprise that wanted to try that. Just like, oh, can't even do that. It doesn't even exist. And now that's within reach of anybody, frankly. It allows us to be much more responsive to our business partners, although it does put us into this position where we can't afford to say you can have that in 18 months. You can't afford to say you just have to wait until the next quarterly release. It forces us and allows us to start delivering in days or weeks, not months, not years. And that's a huge cultural shift for a lot of organizations, because we're sort of in this mindset of we have a software delivery lifecycle, and we have a quarterly release, and we just have to wait, and we have to go through the change review board or the architectural review board or some other process that acts as a brake on our ability to move forward. And I understand why a lot of that was done. I mean, if we put sort of a positive spin on it, we were trying to prevent outages, prevent bad things from happening in production. I get that. It came from a good motivation, but I don't know that it worked all that well. And it typically meant we had to tell our customers no an awful lot. This was really in sharp relief to me at Spring One. I think this was 3 years ago now. And a gentleman from Scotiabank got up and talked about their shift from the traditional quarterly release cycle to doing thousands of deploys a month. Now, I want to stress this took time. This is not something where they just sort of stepped in or like, boom, we're doing releases 1,000 times a month. That takes months and months and months of effort. There's real engineering discipline that goes into that. Probably changes to your approach, changes to infrastructure, et cetera. But it can be done. And what was really striking to me is I had some of my former colleagues were at this particular instance of Spring One, and we were chatting in the hallway. And they said, "Oh, Nate, you've worked with us. We'll never get here." I said, "Well, of course you can. Why not? If a bank can do it, why can't you? I mean, there are a few industries in the world that are as heavily regulated as banks, and for good reason, by the way. But today, speed matters. I remember when I first got started in industry, it seemed like the most common estimate for us to give our customers was 18 months. That'll take 18 months. And that was acceptable back then. It isn't now. Disruption is impacting all of us. There is no industry that's immune from this. You know, yeah. Oh, no. Okay. Sure. Not a problem. It gives me a chance to take a drink. I think this disruption aspect is to me something that is very interesting in our industry. We've had this ability for a long time to say that's how we've always done it, and we can't get away with that anymore. And some of that just comes from never challenging our approach. A couple of years ago, I was doing some work with a client, and they were having performance issues. And so they walked me through their architecture, and basically what it boiled down to is they were processing groups of widgets sequentially. And then at the end of that, they do some aggregation and then move on to the next box of widgets and whatnot. And so I asked at one point, I said, well, does the result of processing widget A have any effect on processing widget B? I said, oh, no. We just at the end, we do some aggregation and that might move some stuff over here, which we then, and I'm like, okay, cool. So could you do that processing in parallel? And you could see there's just sort of this like, wait, what? We didn't even think of that. And as much as I like to pretend I'm, smart, I think I am. I was no smarter than anyone else in that room. It's just I didn't have the baggage of that's how we've always done it. And it's important for us to remember that just because you did it that way before doesn't mean you have to keep doing it that way. And this company, the problem was they've been very successful. They, when they first started, they only had like one box of widgets to process, and they did it in an overnight batch run. That was the easiest, most efficient way to do it. And then as they kept getting more and more boxes of widgets and more customers with bigger boxes of widgets, it just took longer and longer. And I'm sure it was fine right until the day it wasn't. It's like, oh, we could do this a different way, couldn't we?
Okay.
Surely not a problem. Let me bump out of
Well,
there.
Nathaniel, while you're
Whoa.
doing some stuff, can you tell us what for do you like golf? You mentioned that you are doing it often.
Yes, that is the one big positive for me of this whole COVID pandemic is I'm not spending crazy amounts of time on airplanes. I have this application that will actually tell me how many hours I spend in the air. And at first I thought, oh, that's really cool. And then I realized that actually that's very depressing because I did the math at one point and I was spending, I think 1 year I spent almost 3 work months in the air. And it's like, ouch. So I really like being home and being able to play golf and being able to hang out with my son. And my wife and I've gotten in a nice habit of going for a bike ride Saturday mornings after she goes for a run. So, it's there are pluses and minuses, I guess, to this whole being stuck at home thing. But
No, okay,
all right.
yeah,
Are slides
and
good? Can we see everything? Maybe? Hopefully?
well, I don't think so.
Okay, sure.
Yeah,
No problem.
well, Nathaniel, while we're talking about cloud, well, what do you think if everything about this translation would be in a cloud? What will it fix or such problems like disappointing slides or something else? If everything will be in a cloud.
Sure. Well, so the one of the downsides of the cloud is you are handing your infrastructure over to somebody else and you're shifting that risk to somebody else. You have less direct control over that. Now, I would argue for the vast majority of companies, this is a very acceptable trade-off. I think about email as a perfect example. For the vast majority of companies, why do you want to manage your own email servers? What advantage does that have for you? Now, there are certainly organizations where doing it on premises makes more sense. I think I've seen that with like Dropbox. I think had a very public conversation about how they shifted from a public cloud provider to their own infrastructure. Now that was a pretty esoteric example, right? I mean, not everybody has that same set of constraints, same set of demands. I think the other disadvantage I see, and I should use disadvantage in quotes, the cloud lets you do so many interesting things, has so many interesting capabilities that it can be a bit like a toy box for us as developers, and we start playing with all these things without asking ourselves, does our application benefit from this? And so it gives us another set of things that we're sort of tempted to jam into an app, whether it makes sense or not. I was talking to somebody recently that was going on and on about artificial intelligence, and it's like, how does that apply to your application? I mean, what are you trying to do here? And I got the sense that it was really, I want to put AI on my resume. And it turns out it's really easy to add a little bit of that by just clicking a couple of things in my provider, and boom, I've got it. And it's like, that might not be the best thing for everybody. So that's the hard part. Is it's so easy to convince yourself that you need this thing when maybe you don't really.
Okay, but when we're talking about apps, what kind of an app is good for to be in a cloud? Yeah, we talked about a mail. Yes, it's basically the good app to be in a cloud, but it has some security issues. And where is the border between apps which is good for, which is very suitable for clouds, and others are not?
It depends a lot on the app. I can give you one actually a pretty concrete example. I was having this conversation with a person last summer, I think now. Time really has no meaning in pandemic. My wife made some comment. I said, well, I think it's the 233rd day of March, if I remember correctly. But he had a really interesting application. It was an auction site, and so they were contractually obligated in their SLAs to make sure that when a price update happened, it was reflected out to all of the clients within, I think it was like 52 milliseconds. And he was getting a lot of pressure from his management to move that app to the cloud. And so my advice to him was, well, first and foremost, can any of the providers give you that guarantee? And because he had to do an awful lot of architecting and engineering to make that happen. Yeah. Well, cool. Awesome. Cool. Sure. Oh, no problem, no problem. So just to finish that story, he was getting this pressure because at a lot of companies, you've got CEO type people, VP type people who want to be able to tell the story of we're in the cloud. And so they're pushing their apps, go to the cloud, go to the cloud, go to the cloud. It may not make sense. And so for him, my advice was, well, make sure it's even plausible and at what cost before you just say, of course, this makes a lot of sense. All right, so let's get back into this. We are all being affected by innovation these days. I think a lot of grocery stores woke up one morning and were a little surprised when Amazon bought Whole Foods and went, "Oh, now we have to compete with Amazon." I spent a lot of my career actually at an insurance company, and at some point I know it came up that hey, Google's actually a competitor of ours because they're really good at managing information. That's pretty much what we are. And whether it's convenient or not, everybody's a technology company today. Now, I like that because I'm a technologist, but I know that there are other people who are kind of annoyed by this, but that's just the reality. So let's talk about 12 factors. Now, this is also known as the 12 factor app, which is a characteristic of successful apps, at least on Heroku, although I would argue these are pretty good, period, regardless of your deployment platform. One code base in version control, multiple deploys. I don't think version control is controversial anymore. At least I hope it's not. If we're going to share code, please make it a library that's designed to be shared as opposed to just, copy and paste. You need to explicitly define your dependencies. You can't rely on something just being there. If you need it, you have to declare it. Want our configuration be separated out from the code, so anything that varies from environment to environment. And one way to sort of think about this, not that I recommend you open source all of your applications, but could you open source that app if you wanted to? And if we sort of keep that in the back of our heads, it can help us sort of remind us that some of this stuff does need to be separated out. We want to treat our backend services as attached resources. In other words, it should be very trivial to swap in or out different databases, one for local work, one for testing. This is just loose coupling. That's a very common pattern, obviously, for us in software. We want a build, release, run lifecycle. In other words, deployment pipelines. This is our friend. So you've got a step that builds the executable, then we deploy that with the proper configuration, and then we launch that into the proper environment. We need to be stateless. In other words, share nothing. I've struggled with this throughout my career, and I know a lot of people think, oh, it's no big deal. This is one of my all-time favorite tweets. A good friend of mine tweeted this out. They said, if you don't think managing state is tricky, why is it that 80% of our problems are fixed by rebooting? I mean, that is the most common thing we do. I rebooted my machine this morning because it was being a little cranky. So I just, okay, reboot you. And, knock on wood, so far it's been pretty happy. Now, that doesn't mean you don't have state. Obviously, you have state. It just has to be in a durable backing store of some sort or another. I can't rely on the file system. I can't rely on memory. God knows I have violated this throughout my career. If I do, my ability to scale, my ability to recover is hampered. We want to export services via port binding. In other words, we listen for incoming requests on a port, local host for development, load balancers for public facing stuff. We scale horizontally. We scale via process. So instead of throwing more hardware at it, we just add more little things. For most of my career, I could always rely on a big performance boost anytime we upgrade our servers because, hey, look, they're faster. Pretty much tapped that out largely thanks to the speed of light. We need to start up fast. We need to shut down gracefully. Again, these aren't pets that we're going to try to take long care of. They're disposable, for lack of a better term. So we need to be able to start them fast and stop them fast. And this really needs to happen in seconds, not minutes. If it takes too long, the health checks don't finish and bad things come out the other end. And our server also needs to expect that, hey, we're going to tell you to end, terminate once you're done handling whatever traffic you currently have. So stop sending new traffic there, finish your processing, and then go away. We want dev prod parity. Have we ever not wanted this? I mean, when have you ever said, oh, I really wish prod was radically different than dev because that gives me a whole interesting raft of problems to solve? But what this boils down to is I want to go from commit to production as quickly as possible, hours, maybe days, certainly not weeks, which does mean that we need to be a lot more involved in deploys, prod ops, et cetera. And we want these regions to be as identical as possible, which does mean we want our backend services to be the same. It's amazing to me how many people will use one database in prod and another one in test, and then they're surprised that there's problems. We have to treat our logs differently as well. We can't just rely on them being in some file somewhere on a server that we SSH into and then Command F our way through. We can't write to the file system because that file system instance won't be there later. So we just pipe the standard out and then we route that somewhere interesting, which frankly I think has a big plus side is that we now have a whole lot of great tools we can use to consume them. They can be very expensive tools, but also very powerful tools. And then we also want our admin tasks to run as a one-off, so database migrations, et cetera. This is just another way of saying let's have a REPL for the win. And so we want these things to run in the same environment as these long-running processes. Now, you've got an application that you built 5 years ago, 10 years ago, 15 years ago. Guess what? It's going to violate some number of these factors. There's a chance all 12, although that's really, really rare. I don't know that I've ever actually seen an app violate all 12. I'm sure someone has written one. I've just not seen it. In general, the things that we see a lot are explicitly defining your dependencies. This one happens to all of us. It's so easy just to throw that library in there. Do you really need it? I don't know. It works. Don't touch it. Don't breathe on it. Separating out configuration from the code. Oh my gosh, I've hard coded credentials. We've all done that at some point. And you're sitting going, why am I still getting test data? Well, because you have the test database hard coded in somewhere. Like, oops, happens again to all of us. Share nothing. Again, God knows I have screwed this up. This can be a bit of a challenge. A lot of our apps were designed around a specific page flow. You went from page 1 to page 2 to page 3. And again, I've done this a lot. Oh, just stash that in session. It'll be easier. And that's fine right up until you start to load balance. I remember the first web app I ever worked on. We know we're notorious for this, just, always jamming stuff into session. And it worked great until we got to the load balanced version of the server. And then we're all like, oh, shoot, this is a problem. We need things to start up fast and shut down fast. I've written a lot of apps that on startup, they go call the database a bazillion times to load a whole bunch of stuff into memory because, we didn't realize distributed caches were a thing. Of course, in fairness, they didn't exist at one point. Now they do. And of course, the problem here is, well, that impacts your health check because that router, that brain that sits in front looks and says, are you ready to serve traffic? Oh, you're not. How about now? Oh, you're not. Okay, I better spin up another instance. You must not be healthy. Again, dev prod parity. When have we ever wanted dev and prod to be different? We need consistency so that we can have as short a cycle from business person wants this change, that change is running in production as humanly possible. You never want to say it worked in test, it didn't work here. I mean, again, this is not something that any of us have ever enjoyed having to debug. Now, I've had this debate with people. Does my application have to be fully 12-factor compliant to go to the cloud, to get any benefit out of the cloud? And the answer is no, not at all. You can actually get quite a bit of benefit, even if you're only part of the way down that path. It's a great goal. So by all means, knock yourself out. But you need to be ruthlessly pragmatic. You do not have unlimited time, unlimited resources. So you need to focus on the things that hurt your ability to go to the cloud. So long startup time means it's really hard to do elastic scaling and self-healing. So you have to ask yourself what needs to change, what can I delay, defer, etc. It's really a continuum, to be real frank. And so I like to use this example. You get your 12-factor compliance along the bottom. I get more benefit as I go down that path. I don't have to get all the way there necessarily, certainly not on day one. Now, you'll hear people talk about the 15-factor app beyond the 12-factor app. I think Waters is now talking about like the 1-factor app. However you define it, to maximize what the cloud gives us, we really need our applications to be designed to take advantage of that. And unsurprisingly, your heritage applications are going to fall short. That's okay. You need to opportunistically and ruthlessly, pragmatically, excuse me, refactor them. Now, if you're building Greenfield today, well, by all means, go cloud native. I can't really see any reason why you'd want to build legacy today. That, of course, brings us to microservices. Now, microservices are near and dear to my heart. And I think they're ultimately a reaction to monoliths and these sort of heavyweight services that we've written before, the SOA world, as well as sort of these cloud environments. And let's be clear, monoliths hurt. I've never had much fun on these monolithic apps. Your developer productivity tends to not be great. You get started and there's like this dictionary size getting started guide that somebody drops on your lap on day one. And let's be fair, if you've got a multiple thousands and thousands of lines of code, like it takes you a long time to get your head wrapped around these ginormous code bases. It's no fun to be in a project knowing you can't really contribute. And in some cases, you can't do much for months, weeks in some cases. It's just terrible. I was on one organization where the expectation was it'd take you about a year to be productive on their code base. It's like, ouch, that's no fun. I understand part of the reason why we use quarterly releases is because, well, even if you just change one or two things, you got to deploy everything, which means we probably have to test everything just in case something might have popped up somewhere. And of course, scaling was really difficult because we had to scale the whole application. There was no way just to say only the order processing piece needs some more capacity, so let's add that. It can be really challenging to evolve these systems. Now, we're all familiar with the second law of thermodynamics. I like to refer to this as the teenager's bedroom. I am the proud owner of a teenager. My son turned 13 earlier this year. And so at some point this spring, I was putting something in his room or taking something out of his room, and I had a hard time kind of figuring out where the floor was. And so I made a comment to my wife that perhaps we should suggest he clean up his room. And she looked at me and said, "What hill do you want to die on today?" And I realized it wasn't that one. And as much as I wish my son's room was a little more organized, I also realize he's just dealing with universal forces here. The universe wants to be disordered. And as much as we strive against it, our software is not immune from this. I mean, we've all started on a project and said, this time we're going to do it right. And 6 months in, 3 months in, oh, wow, we crossed the streams. We had to patch something late at night, or, oh, there was a bug that we had to fix really, oh, the VP needed this for a demo. And, we did some things we weren't proud of. Modularity tends to break down, and next thing you know, it's taking longer and longer and longer to add new functionality. And I think that's frustration over that is part of what's given birth to this, new style, this microservice thing. Now, it's very clear there's no one definition. This is very much you'll know it when you see it. It's in the eye of the beholder. And I can't help but notice that in our industry, we love to argue about the definitions of meta boards. This is something we do time and time and time again. It's not particularly practical. I'm rather partial to anything that can be rewritten in 2 weeks or less because it reminds us they should be small, which of course does then ask, well, how big should a microservice be? And Sam actually put a video out earlier this year about that. And I think it's well worth a few minutes of your time to take a glance at that. You hear a lot of people talk about this in terms of 2 pizza teams, and that's great. I love pizza, but I don't think it's a great way of defining this because it doesn't tell you how many services a 2 pizza team can handle. Is it 5? Is it 20? Is it 30? And this is a question one of my directors came to me with my last organization. Of course, I can't give an answer to that because it depends on the volatility of those services. If those services are changing all the time, my 2 pizza team might only be able to handle 5. If they're pretty stable, solid, refined, that exact same group of developers might be able to handle 10, 20, 30. So I think it's more important to look at this in terms of characteristics. Small, focused services. They do one thing, they do it well. It's this Unix, Linux-like model of pipe simple things together to get complicated results. They should be independently deployable. This is one that gets violated a lot. Actually, a friend of mine and I were talking about this, and he said he was at a company where they were doing microservices, and they screwed this one up. And he said they had 7 microservices that if you touched any one of the 7, they all had to be redeployed in the right order in order for everything to work. Oops. They need to be independently scalable. They can evolve at different rates. Developers love the fact that I can choose the right tech for the job. I can finally insert esoteric language or database here. Although that's not the best reason, by the way. It's just one of the freedoms that we are given. They're built around business capabilities. And ultimately, what this boils down to is it's high cohesion, low coupling. This is the zeroth law of software engineering. High cohesion, low coupling. If you look at the Gang of Four Patterns book, a huge number of them are basically a variant on high cohesion, low coupling. Now, I would argue microservices are high cohesion, low coupling applied to services. Now, it is an approach, a style, a pattern. It is not Mjolnir. It will not solve every problem you've ever had. It will not allow you to, call down lightning and smote your enemies. Besides, you still need to be worthy to pick it up, apparently. Now, I know a lot of developers seem to think of it as the hammer that solves all their problems. It's just a tool. That's it. And the challenge for us is knowing when to use which tool. Last year, my wife and I had our basement finished. And since I am a software person and know nothing about hardware, I am not capable of doing that. So we wrote checks to other people to have them do the work. And when those folks showed up, they didn't have one hammer, that whole toolbox full of hammers. And they knew when to use which one. And there's a difference between the framing hammer. In fact, there's even different people. This surprised me. I didn't realize that there was this level of specificity. But my general contractor told me that the person he uses for framing is great at framing, not so good at finish work. So he doesn't let him do finish work. So that's the real challenge, is knowing when do I pick up which tool. And for us, I'd argue the real thing is we need to use them wisely. And that's why I wrote this piece about responsible microservices, otherwise known as should that be a microservice. And as my friend Simon Brown likes to say, hey, if you can't build a monolith, what makes you think microservices are the answer? And that leads me to this. I was talking with Spencer Gibb about this, and he really gave me this concept. So I'm going to throw this at you here. But we have to remember that there's this axis of modularity versus distributability. And so we're all familiar with the big ball of mud, and that sits over here in this corner. And so a lot of us are like, oh, this sucks because it's neither modular nor distributable, and that's bad. And where we really want to be is microservices. And so we're all like, yes, let's take the big ball of mud and go all the way to microservices. Except the problem is that's generally not where we land. What usually ends up happening, instead of getting this microservice nirvana, is we have a distributed big ball of mud. And this is bad. This is like the worst of all worlds. We think it's distributable. It's really a pain to do that. And we're still not any more modular than we were before. So that's not good. And so what a lot of companies will do is they'll build a modular monolith first. And so they'll gradually shift that big ball of mud over to a modular monolith. And then from there, they'll go to microservices. Although you're starting to see a lot of chatter today about macro services or right size services. And so some people will go from the modular monolith to right-size services, or then from microservices to right-size services. Regardless of how you get there, it is a transition. It's not just snap your fingers, wave a magic wand, and Osseo distributed thing. It's just not how it works. And sometimes the modular monolith is good enough for what we're trying to accomplish here. I'm going to briefly touch upon serverless, because we've seen again this shift of IaaS to CaaS to PaaS, and people are like, but what about serverless? What about functions? Everything again is as a service today. That's kind of the in thing right now. And of course, as a developer, you're sitting going, well, hang on a second, I just refactored to cloud native microservices, and now you're telling me I need to do a bunch of functions. That makes me kind of grumpy, or worse, I'm going to go flip a table. It's funny, when my wife first saw this slide, she looked at me and she said, what's that? And I said, well, it's table flip. And ironically enough, she's now looking over my shoulder. And she said, what do you mean? I said, it's table flip. See, arms in the air, chairs upside down. And she's kind of looked at me and said, you have a weird job. I said, you're not wrong. So please don't throw that code away quite yet. I think it's fair to say that FaaS is a subset of serverless, though you will hear those terms used interchangeably. There are still servers. We're just further abstracted away from them. We're not responsible for provisioning, updating, scaling, which of course led my friend and colleague Paul Sarkovsky to tweet this out. What idiot called it serverless and not DevOpsless? I just don't think it runs off the tongue quite as nicely, but I'll take that up with Paul next time I see him. In other words, it's someone else's problems, which does kind of lead to this. Sam tweeted this out a couple of years ago saying, wow, isn't this actually worse than what we had before? Because all these things need to be patched. And that actually prompted a response from Josh to say, well, right, that's why we have all these platforms and these public cloud offerings, because now you can just focus on your app and let other people deal with all that. And so it's important to understand the layers that we have here. IaaS sits at the bottom of all this. This was kind of the beginning of the cloud cloud for most organizations. And then we came up with containers. And so that's cool. You have to bring the container to the party and everything that entails. And then that container environment gives you scheduling and networking primitives and all that kind of stuff. Well, if you leverage a platform, well, the container comes along for the ride in various ways, shapes, and form, and you're responsible for your application code. And you let the platform give you the images and the networking primitives and maybe a marketplace and quotas and things like that. If we go to serverless, well, the container is provided as well. And arguably even the application is, so to speak. And all you have to write is a function, 5, 10, 15 lines of code. And execution of that function, scaling that function, binding to the event stream is all handled for you. And so the real difference between these different approaches is ultimately, what am I responsible for as a developer versus what does my tool or platform give me? They're just different levels of abstraction. So another way of thinking about this is sort of the layer cake. There's still hardware. It's always going to be hardware. IaaS layers on top of that. And for some applications, that's the layer we need to use because we have very specific needs. And I'd say that's pretty rare, but it's still possible. I can use a container to further abstract me away from that. I could use a platform if I don't want to have to even deal with containers. And I can use serverless if I don't want to deal with any of that at all. Now, the thing is, the lower down I go on this, the more flexibility I have, the more I can control. If I need to know this exact firmware is installed or these exact chips are used, I can do that if I own the hardware. But that also means it's a lot more on me. The higher up I go, the lower the complexity, the more operational efficiency I get. I'm also hammed in a bit. You get to serverless, I can't use whatever language I want. I have all sorts of other interesting sort of restrictions in terms of how long can this execute. But I do think it's in our best interest to push as many things up that stack as possible. Now, there's a whole bunch of different options here. All the public cloud providers have their own instance of functions. There's several open source variants as well. It definitely suffers from that shiny new thing curse. I'm kind of the opinion developers are a lot like dogs chasing squirrels. It's like, ooh, look, shiny new thing. Let's go run after that. And there still is a bit of that there. So be careful we're not falling into sort of that lemming jump off the bridge approach just because everyone else is. Now, there are a lot of very good reasons to utilize serverless. It's not just a new way to cloud. You get some very serious efficiency gains here. There's good developer efficiencies, less and less for us to worry about, less for us to try to get our heads wrapped around. It gives us a higher level of abstraction, allows us to focus just on the implementation of this business problem, not all the infrastructure. Do you care what OS patch you're running on? I mean, is that something you really want to worry about? Where do you want to focus your attention? I talked about this earlier, but we want to think long and hard about where the value line is and do as little undifferentiated heavy lifting as possible. This is one of my all-time favorite slides. This is my former boss, Andrew Clay Schaefer. Good job configuring servers this year, said no CEO ever. He's absolutely right. It's important work. It still needs to be done, but this is not the kind of thing that we get bonuses, raises, promotions based on it. We need to focus on business problems, not underlying plumbing issues. Now, the other big plus here is we get some major resource efficiencies. One of the things that gets people very excited about functions, if it has not been called for a while, we can terminate the container. And you're not paying anything at that point. It's zero cost. Request comes in, spring a new instance up, and away we go. Now, what does catch a lot of people in this functions world is the first million or so are free, with, of course, that same caveat of additional fees may apply. So data transfer fees, other services, etc. Functions are not free. Please, 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 always just have this like branded on your forehead when you go down this path. It looks free because it's this strange fractional cost, which is based on number of requests, run duration, resource allocation. And so it can be really hard to figure out exactly how much this will cost, but it's not free in any stretch of the imagination. Now, that said, for certain workloads, it's as cheap as it gets. We get some very serious operational efficiencies. Again, some people call this sort of serverless ops. Somebody has to deal with it. It's just not us. This is where the platform is your friend. It is a great tool. It is not a fit for every single workload. So I tweeted this out a couple summers ago. Dave Sire was talking about this at an event we were putting on, and this just sort of came to me that if your use case is latency sensitive, don't use serverless. You see some people today say, "Oh, Java's too slow," or this. It's got nothing to do with that. You made a bad architectural choice. And also then I saw this tweet and it made me both laugh and cry at the same time. Someone suggests it's a best practice to avoid cold start times on a cloud function by writing a second function to constantly ping your first one. Like, please, dear God, no. I'm glad I wasn't at that event because I would have pushed back pretty aggressively on that. Okay, so we know what our options are. What do we do with our legacy portfolio, our heritage apps? Well, figure out where you are first. Assess your applications. Some of them are going to be great candidates, others not so much. So there's certain things you're going to need to know about your application, certain technical characteristics. What's your tech stack? What version of the tech stack are you on? How many users do you have? Hundreds, thousands, millions, billions? How many transactions are you typically dealing with? What components do you use? What third-party things do you use? What are your data integration points? What's your data access technology? Do you have an internal framework? Of course you do. How many? What does that look like? What about batch jobs? What's your current deploy process look like? Do you already have automation in place? Do you have CI/CD, or is this all going to have to be rolled from scratch? How's your test coverage? Now, be careful with this one. A good friend of mine told me this story last year, and it still makes me both, again, laugh and cry. He was brought onto a project because they were having regression issues every time they had a release. And so the first thing my friend did after kind of getting everything set up was ask about tests. And their tech lead's like, oh, we're very proud of our test suite. We have like 92% code coverage. My friend's like, wow, that's really impressive. And you guys still have regressions? Like, yeah, I know, we can't figure it out either. That's why we brought you in. And so my friend starts digging into it, and at first he sees a pattern. He thinks, well, it's just isolated. It's just in these one or two places. And then he realizes pretty quickly it's not. It's everywhere. And so he goes back to the tech lead, and he says, listen, I was looking at your tests, and I couldn't help but notice that none of them have asserts. And the tech lead's response is, well, yes, but we have like 92% code coverage. My friend just sort of hung his head and said, okay, I think I know what your problem is. So we need to reassess this, or assess the refactoring effort. There's certain red flags to be aware of, any vendor dependencies, writing to the file system, reading from the file system. Do you have long startup times, long shutdown times? Are you using any non-HTTP protocols? Do you have hard-coded configuration? Do you have any container-based shared state? Are you doing distributed transactions? Every other month or so, someone asks me, how do you do distributed transactions in the cloud? And I just say, you don't. And they go, well, but how? It's like, you have compensating transactions. It shouldn't be a surprise. If you've ever bought anything at a store that has a return policy, do you think they keep that database commit open until the return period ends? Of course not. They commit that transaction, and then if you bring the shirt back later, well, they go ahead and put out compensating transactions to roll that back, to give you your money back, to put that back into inventory. So we need to evaluate our applications for 12-factor compatibility. Again, it's a sliding scale. How far out of alignment are you? You're going to need app experts to do this. I can't do it for you, I'm sorry. And it doesn't happen instantaneously. It takes a few hours per app usually. You probably want a little application to keep track of the data. I want to stress that Excel is not an application platform. Okay, I had to do this in Excel with a 400 plus app portfolio. It was a pain in the keister. If you've got 3 or 4 apps, it's fine. But believe me, if I didn't have a friend who knew how to do Excel macros, I would still be wading through Excel files today, even though I haven't been in an organization for 3.5 years. These assessments are going to bucket your applications: low, medium, high, red, yellow, green, whatever scale works for you. And then these cutoffs are pretty arbitrary, so don't be afraid to do some sanity checking. And you also want to factor in some non-technical things. Like, what's the business value of the application? How much business value do we get from this? What's the life cycle of this application? Is it strategic? Are we going to continue to invest money in this, or is this going to go away soon? We're trying to run business off of this. Now, be cautious on retirement. That's not a hard no. You need to ask when. So I made this comment to somebody this a while ago now, and he just laughed. And I said, why is that funny? He said, oh, when I started the app I was working on, I was told it was marked as sunset, so don't get too attached. And I said, oh, okay, yeah. He said, yeah, that was 25 years ago. That app is still running today. So if it's going away in a few months, obviously it's probably not worth the transition effort. If it's going to be around for a while, it probably is. Now you need to do some planning. What's your desired end state? Trying to go all the way cloud native, just get it running. There's going to be a certain amount of refactoring here. And so we can get into some interesting debates about, how long does it take to forklift an app? The only answer I can really truly give you is it depends. Do a pilot app or 2 or 3, you'll get a feel for it. My experience, it's probably a week or so to get an app running. That's not optimized. That's not everything is up and running exactly the way you'd want it. Don't be afraid to talk to experts. We've got a lot of folks who've done this. time and time and time again with hundreds of companies, dozens and dozens of applications. I'm a huge believer in having a lab that helps people with this, helps teams migrate. That should be a pairing experience, by the way, so we can grow that skill set. And they need to create a roadmap. And what's interesting, my friend Rahit kind of gave me this visual, so I'm going to share it with you here. And this is something that he uses with our clients. He says, you start with business value, low, medium, high, and then you've got what is the effort to actually refactor it. And again, that's sort of low, medium, high again. And so your apps are going to all be distributed across this sort of continuum of lots of business value, not a lot of business value, easy to move, hard to move. Well, you want to start with the low hanging fruit. So you start with the things that are high value, low effort. Then you want to move to the high value, harder effort type applications. Then you start thinking about low effort, low business value. And then, quite frankly, you think about just getting rid of anything that's low business value, a lot of effort. Can I retire it? Can I replace it? So that'll start to give you a sense of when these applications can move. And I like to stress it doesn't have to be the entire application. You'll discover that parts of it are easy, parts of it are hard, so don't be afraid to move what you can. I have had some difficulty with terminology here because people think of application very differently. Developers, we tend to be a little more fine-grained. VPs tend to be a little more coarse-grained. So don't be afraid to opportunistically migrate as you go along. Just have a rough idea of when. And of course, ask yourself, does this work for our stakeholders or not? And then what can we ultimately do to accelerate that plan? All right, well, I'm going to go ahead and break here, and we'll see what kind of trouble that gets us into. I don't know if we have any questions, but I will stop my slides for the time being.
Yeah, thank you very much for the speech, Nathaniel. It was very interesting. I hope it was very useful not only for us but for for all of our listeners. Well, guys, I want to remember that we have a Telegram chat where you can write your questions, and we will ask Nathaniel, and Nathaniel will try to answer on your questions.
I'll do my best.
Well, yeah. Well, we have questions. The first one is, well, you mentioned pains of monolith application, but is it really so bad? And maybe it is good to start development from monolith app, as Martin Fowler recommends.
Yeah, that's a good point. We tend to always think of monoliths as bad, and again, you can have a modular monolith. There's no rule that says the monolith has to be poorly factored, has to be hard to work on. You can have well-written monoliths, and there's a pretty compelling argument that says it's hard sometimes if you're thinking about a microservices architecture to sort of know a priori where those things might break up nicely. And so building the monolith first sometimes will make it easier to find where those seams are in your application. So, I'm by no means am I anti-monolith, so to speak. It just tends to suffer from a lot of the maladies, that we see in software. Again, I think it's interesting that none of us likes the big ball of mud, but that's by far the most common architectural pattern we have. And I want to think most of that's accidental, that we're doing this without really thinking through the consequences. But there's nothing in stone that says a monolith has to be hard to work on, hard to refactor. I've certainly had monoliths that I've been a part of that had 95% code coverage, that were well structured, that things were again follow that high cohesion, low coupling sort of concept. So how you choose to sort of distribute it is a different story. Now, there are still some negatives there, in terms of scaling, and it can be harder to do linting. It can be harder to run things through your pipeline. It can be easier if things are broken up. But that doesn't also mean you have to go all the way to having thousands and thousands of services. There's downsides to that architecture as well. And so the challenge for us really is that we have to do the effort of saying, where do I get the most bang for the buck? What's the right way to attack this problem?
Thanks.
And probably I will ask some question about microservices. And I currently see huge range of people doing what's actually mean microservice. and what's the sizing for it? And like somebody tried to put exactly this 100 of them. So what your thought on it, like in 2 words?
Yeah, again, I love anything that I can rewrite in 2 weeks or less because it reminds us these things are supposed to be small. But I love Sam's video is well worth, I think it's 8 minutes of your time because he gets through some of those issues. There's that they should be as small as possible, but no smaller. And I know as developers, we always want to have like a hard and fast rule. There's just no easy way to do that. And that's where we have to be professionals. We have to look at it and say, I think there's multiple concerns here. I think that's probably a better way to think about it. Is this doing 2 or 3 or 4 things? It should be doing one thing. And there are some things we do that doing one thing is going to take thousands of lines of code. And that's okay. That doesn't mean you're wrong, but where we tend to have issues here is when, I'm now taking this and it's doing A and B and C instead of just A. And that's where I think the pain comes from, frankly. So, I wouldn't get locked into any specific number of lines of code or anything like that. You got to let your own kind of intuition sort of speak to you, and don't be afraid to use your own, sort of gut instincts to say, yeah, I think this is getting too big. It's too hard to handle, or, it's doing too many things. Yeah, it's probably time to break it up.
Okay.
Okay,
well,
so
the next.
basically single responsibility principle in full world.
Exactly.
Thank you.
Yep.
Yuri?
Yeah, thanks. Well, the next question is, I think the provocational question. Well, we're talking too much about cloud platforms and something else. Well, can you tell us what is your favorite cloud platform and why?
I'm very agnostic, to be honest with you. There's bits and pieces I like from all three. Though the big three, I guess I shouldn't just use them. There's certainly others. It's funny. I teach a grad school class at the U of M on and off, and it's on the cloud. Imagine that. And so one of the things that I strive to do in the course of a semester is get my students to play with Azure, AWS, GCP, so they start to get a feeling for what they have. I mean, the service offerings are relatively on par, parity. There's obviously some differences there, a difference in maturity, et cetera, but they all kind of have the same stuff. And it's just a matter of what works best for you. And a lot of that isn't just as simple as, well, I like this vendor better. It could be, we already have an established relationship with this vendor, and that might be the path of least resistance. I already have an ELA with them, and so that's the easiest way to go. But what always fascinates me is, every semester I'll get, it's never an even number of students in terms of who likes which block, but I've always got some that love Azure, some that love AWS, some that love GCP, and some come into it with a preconceived notion, and then at the end of the semester, like, well, now that I've actually played with all of them, I like this one better, or I like this one better for this and that one better for that. And that's perfectly natural as well. Now, I would argue for almost any big company, not a 2-person startup, but if you're Fortune 500, Fortune 1500 company, there's a pretty good chance you're going to use at least 2 out of the 3 vendors. And there's also a decent chance that you might have to draw a line through one of the vendors because they're a competitor of yours. So now, I don't think you want one app to be deployed on both AWS and GCP. That ways lies madness. But I was at a company that we were big enough that we had one division that was almost entirely .NET, and we had a division I was in was almost entirely Java. Well, for the .NET folks, let's be honest, Azure was the path of least resistance, and so that's what they're advocating for. Whereas we were more interested in AWS and GCP. We're big enough where we're going to have both contracts, and that was going to be perfectly reasonable. So if you're in this division, you're going to use GCP. If you're in that division, you're going to use Azure, and I think that's fine. I think that's natural, frankly.
That's really
Okay,
awesome.
thanks, Nathaniel. Yeah.
And we have like 3 more minutes for discussion, and we have one more question about distributed transactions.
Okay. Bring it on.
Why people even come with distributed transactions? Why they need them?
I don't know. That's a great question. I mean, it's like I say, about every other month or so, I run into somebody who's but I have to have distributed transactions. And I haven't had anybody really give me a great answer to that other than that's how we've done it before. And the thing that I always like to point out is I don't know that they've ever worked that well before we went to these heavily distributed architectures, but to try to do it in a cloud environment, that way lies madness. Again, I love if you go to a store and you buy something and there's a return policy, those transactions are committed to the database. They don't leave them open for 30 days until the return policy is expired. If I bring that shirt back, I bring those shoes back, whatever it is, a new transaction to put it in inventory, a new transaction to refund my money. That's how that works. I don't understand why that's so bizarre for people to understand. It's far more common to do compensating transactions than it is to try to do distributed transactions. I mean, this is how banking works. This is how finance works. I mean, I just don't know why it's so I guess difficult for some people to accept.
Yeah.
I think that falls into, quite frankly, that's how I've always done it. And I think some people view it as, well, my app is really complicated because I have distributed transactions in it, and I obviously must be a better developer than you are because my app has distributed transactions. That's irrelevant, But anyway, see, now you got me on my soapbox.
Okay, well, and when you come from banking, you completely do not understand these people because, we did it for 20 years.
Right.
What transaction you talking about? I did not have any.
Right.
So,
yeah.
well,
I totally agree. I mean, they're not nearly as common as people want them to be. And, again, I don't understand the folks who were big on distributed transactions in the first place. But, hey, to each their own. I get it. I mean, it's fine.
right?
I think I think people who like distributed transactions, they just like difficulties, and that's all.
Yeah. Oh, this industry fetishizes complexity. There's no getting around it. I think we would be far better served if we given the choice. The simpler solution is almost always in our best interest. We love to see how complicated things can be and show off how smart we are. It'd be far better for us and the developers that come after us if we had chosen the simpler approach.
Yeah, like putting in a simple calculator into the cloud, for example.
Exactly.
Okay.
B symbol sounds like a good closure for this talk, especially when you migrate to cloud, which is already overcomplicated.
Absolutely. Thanks, everybody. I appreciate your time today.
Thank you. Really enjoy your talk. It was really great.
Yes, thank you.
Cheers.
Thank you for your experience, Nathaniel. But now we should finish this talk and go into discussion zone with our attendees. And Michael and Yuri can help you with this. Okay, thank you. Bye bye.
Cheers.
Bye.
Bye.